Hi, so in this short video we're going to explore the hot topic of Kubernetes Cluster Federation, or really what you're going to do when you outgrow a single master with a single CNI or SDN controller in Kubernetes and you need to scale out. So as ever, we're going to provide you with all the code and a wiki at the end of the video, so there's no need to take notes. You can just watch me deploy, and then at the end you can take the code, you can make it your own, use it for your own purpose. So at some point you're going to outgrow a single Kubernetes master. Masters can be huge, but scale is not the only reason that you might need multiple clusters. So if you're an architect, you might have specific resilience requirements or requirements around failure domains that mean you're going to end up with several masters, maybe with workers distributed for on-prem or public cloud or a combination in hybrid cloud. Or you might have requirements around, for example, geographical resilience, where you just want to spread applications across different data centers in different places between public and private cloud. You don't want all your eggs in one basket. So whether you have 2 Kubernetes clusters, each with a master and each with a CNI like Contrail running, or you have 200, the question remains, how are you going to stretch those network services and those namespaces across multiple sites so that your applications can be deployed anywhere and still function? So the answer is federation, and for this video we'll be talking about Contrail-SDN federation, because that's how we federate those network services. So at this point I'm sure you're already familiar with how a Kubernetes cluster looks, where you would have a kube master somewhere, you'd have a CNI handling the network services, in our case it would be Contrail-SDN as a CNI, and then you would have a number of worker nodes. And inside those worker nodes, you'd be deploying pods and services within a namespace. Namespaces typically would be isolated from each other unless otherwise desired. So for example, an ingress might provide a load balancer. So all of these networks and services get represented in the SDN, which is Contrail. So this is a single cluster. But as I mentioned, there's going to be a point in time where you outgrow a single cluster and you need to look at federation. So I've shown 4 Kubernetes clusters here, and as you can imagine, as you scale up, your developers will want the ability to assign pods and services in a namespace across multiple clusters transparently. Now these namespaces could be isolated from each other, and they would expect that isolation to be maintained even if the application is stretched across multiple Kubernetes clusters. So federation is the way we do this. Contrail controllers run BGP, and you can tell a controller that it has another controller as a peer. And when you do that, those controllers start to share information about the network services in the tenants for the cluster that they're managing. If you then go into the namespace and assign a root target, it's a number. Let's say we assign our blue tenant a root target 1000. If we assign that to a blue tenant in all of the nodes, then the SDN automatically stretches and provides reachability within the blue tenant for all of the Contrail controllers that it's federated with. So at this point your developers can deploy a blue tenant in all 4 nodes, and the pods and services will get reachability between clusters automatically. Now the way the SDN does this under the hood, if you remember, we talked about vrouters in worker nodes and how an SDN like Contrail builds its network services with overlay tunnels. Once we federate controllers, if your blue pod here tries to connect to your blue pod here, a tunnel is formed between the worker nodes in the 2 federated clusters, and this is done automatically. So you start to see how federation, network federation, provides a way to scale up across more than one cluster. Now what I'm going to show you in this short video is a really cool stack that can build between 1 and hundreds of federated Kubernetes and Contrail clusters. It's going to put applications in them, it's going to pre-provision everything for you so that as the stack comes up, with however many nodes you select, you can get straight on to test Federation and to see how it's going to help you in production as you scale up. So I've separated this Federation demo into two stacks. The first stack is very simple and just builds infrastructure. So a VPC, public-private subnet, NAT gateway, internet gateway. There's nothing special about this stack. The reason I've split it into two is a lot of my customers already have infrastructure up in AWS and they just want to deploy into existing subnets. So they might already be running VPN gateways, direct connect gateways, transit gateways. This very simple setup sits in internet. If you already have infrastructure, you can just skip stack 1 and go straight to stack 2. Stack 2, as I mentioned, it's a brownfield, so you can deploy it into existing infrastructure, so existing subnets and VPCs. And it's going to create an auto-scaling group, and that auto-scaling group's going to deploy between 1 and several hundred. You can decide all in one Contrail and Kubernetes nodes. So these are separate standalone clusters where I'm merging the Kubernetes master, the worker, and the Contrail CNI and some test applications all into a single EC2. And this is really so you can experiment with federation. As this stack comes up, there's a great deal of automation. So it's not only going to fetch Kubernetes, fetch Contrail and integrate them, it's going to use my YAML deployer to deploy Contrail as a CNI. So this is the same YAML deployer you saw me using in, for example, the EKS demo. In this case, all I've done is I've stripped it back so it's not doing HA anymore. And that's just because we're not interested in high availability here. What we're looking at is federation. Multiple Kubernetes clusters with network services stretched across them. Of course, we can do both at the same time. So in addition, I'm going to deploy test applications into two namespaces, into the default namespace and into a testing namespace. And this is so you can get started playing with federation the second the stack completes. Now all of this is configurable, and in the wiki at the end I have a breakdown of all of the parameters, and you can turn these things on and off. Now as with my other stacks, I also have an option to deploy controlled management access from internet. So I'm going to go ahead and deploy the optional stack 1 just to deploy the VPC, the subnets and the infrastructure. So you can just take the default parameters, it's just the subnets that you want to use. I'm deploying into EU West, which is Ireland. It should work in all regions, so I'm just going to go next. I'm going to go next again, and I'm going to create the stack. And this stack is just going to take a few minutes because there's not much in it. So as you can see, our optional stack 1 has completed, and it took about 3 minutes. So at this point, you're going to see a new VPC, and by default I'm tagging the name with the word K8S Federation, and I'll do that with all of the resources that are to do with this stack. There's no specific requirements for stack 2 other than internet access, because it's going to fetch the packages for Kubernetes and for Contrail from internet. So as always, I'm giving you the steps in the wiki. So if you prefer, just follow the wiki and it says click the link, next, 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 deploy stack. I'm also giving you the CLI because a lot of people prefer to launch CloudFormation from CLI rather than via the GUI. So let's move on to stack 2. Stack 2 is a much more complex stack, and I'm using all the tricks in the book to deploy these clusters fully integrated and ready to go. So this is a great stack to look at if you want to learn CloudFormation, Cloud Init and Contrail Python in order to configure the bits and bobs that we need for federation. The stack's written in a way to be clear and concise. It's essentially doing something in Python for each action that I want inside Contrail, and that's intentional because I'm using this stack as a trainer. So again, let's click the launch stack icon. It's picked up our stack from S3. There are a lot of parameters in this stack, so only a few have to be configured. Defaults can be left for the others. So let's use the wiki, and it's going to tell us what needs to be said. So the next thing the wiki says to do is click next. I've gone ahead and done that. You then click next again, and in the wiki it points you to this. So these instances are given IAM capabilities to run 2 AWS commands. So what this is about is, in order to build up the BGP and configure these instances, they need to know the IP address of all the other instances in the auto-scaling group. By ticking that box, you're giving the instance permission to ask AWS to tell it the IP addresses of the other nodes so that it can configure itself and it can configure its BGP peers in order to talk to those nodes. Create stack. Okay, this stack's going to take about 15 minutes to deploy. It's not going to say it's finished until at least one of the nodes in that auto-scaling group has actually completed its user data. So it completes its user data when Kubernetes is deployed and built, when Contrail is deployed and built, when the test instances are deployed and built, and all of the configuration, including the federation, is ready. So when it says ready, it really means ready. All of the nodes are built in parallel. So it's going to take 15 minutes, whether it's deploying 1 node, 2 nodes, or 100 nodes. So I'm going to come back to the video in a couple of minutes just to show you as the services are being created. So the stack hasn't finished yet, but I thought you might find it interesting to show you some of the services it's creating. It's building a launch configuration and an auto-scaling group, and you can see the auto-scaling group, it pulled out that 10 that we put in the stack, and that's the target for the number of instances that we're going to deploy. And if I now go to EC2, so you can see it's deployed a Contrail command instance and 10 separate all-in-one Kubernetes and Contrail clusters. By all-in-one, I mean the master, the worker, and the CNI Contrail, and test namespaces with applications inside, all sit inside a single EC2. So it's not the sort of thing you're going to run in production, but it's great for a test setup like this, where you just want to play around with federation and see how that's going to go for you when you scale your live sites. So we'll return when the stack's finished. Welcome back. As you can see, stack 2 is now completed, so you're all ready to play. If we go look at the instances, yep, they're all up and running, of course. Now, as ever, if you look at the output for the stack, it's going to give you a clue about how to connect. We don't know how many instances you're going to deploy, 1, 2, 10, 200, but AWS assign the IP addresses. So as a convenience, what I do is I put a script into the command instance to very easily NAT for SSH access from internet to any of these instances, and also to the Contrail GUI, because you probably want to have a look around. So I'm going to show you how that works. So you see here it's saying take this command. So I'm just going to copy paste. I need to change the SSH key to the actual key that's going to log me in. Remember, you specified an SSH key in your stack, and we're in Ireland, so this is my key. And then you see at the end it's asking you for a node IP. So every node in the EC2, in my case there's 10 of them, gets an IP address. So I'm just going to grab one of those IPs, a random one. I'm going to paste it, and it's going to run that little script. Now you can run this script over and over again, and it's going to connect you to different nodes one by one. And it's telling me that if I now use port 222, I'm going to SSH to the node that I selected, this node here. And if I use port 8143 in my browser, I'm going to get the Contrail GUI. So something to note, if you switch nodes, you need to clear your browser history. Okay, so let me change the port to 222 as instructed. It's always port 222, by the way. I'm going to sudo bash because I want to act as root. And let's see what we've got. So there you go. Look, we haven't logged in, we haven't configured anything, and you can see what's been built for us is pretty cool. This is a full Kubernetes. It went and grabbed the code from Kubernetes repos, Contrail as a CNI, all integrated. And if I do a -o wide, if you look carefully, you can see some of these pods are in overlay. So core DNS is running an overlay, and there's also here a debug pod in the default namespace and another one in the testing namespace. and I deploy these for you so you can just start to play with federation straight away. So why don't we just connect to one of these pods, kubectl execute -bin bash. Okay, I'm inside the pod. There's a lot of tools in these pods. You might find them quite useful, including load and performance testing tools, which we can use actually in this video. But you can see here I've picked up an IP address from my pod subnet in overlay. I'm going to note that one down. There we go. And then let's switch to another node. So remember that script that says the node that we want to connect to. Screen again, I'm going to pick a random node. This one got 213 as its IP address at the end. So let's switch to node 213. And we just go straight back in on port 22. So I can just use my history. And I'm now in node 213. kubectl get pods or namespaces. And it's going to look exactly the same. It's a different node, but it's built the same way. And if I kubectl execute and jump into the default namespace pod, I can ping to the default namespace pod in our other cluster. So what I'm doing here is I'm pinging between two pods in two different clusters in the same namespace. This is federation. I'll show you in the video how that's configured towards the end, but let's have a little bit of fun. Let's do an iperf3 server and ampersand. Here we go, I'm running iperf server. Now let's exit. And let's switch to another node. Again, I'll pick a random one. 130. 130. Port 222. There we go. That's 130. So bash kubectl get pods or namespaces. And again, we're the first people to ever log into this node since it was built. In bash. But this time, let's do an iperf client. So it's -c and the IP address of the server. And there you go, it's performance testing. So that's running a load, no tweaking, no optimization. We can make it go faster, but I mean, look at it, it's amazing. These are small M5 instances, nothing special, no guaranteed throughput running in AWS. You want more throughput, use bigger instances, pay more money. We're getting pretty much 8 gig in the overlay, 8,000 million bits per second. Is amazing throughput. And that's between separate clusters. So all 10 of our clusters are federated in a mesh. That's what I do in the stack. And it's the same for the namespace. So, you know, you can jump into the namespace pod. You'll be able to run the same load across any cluster. And of course, this is an isolated namespace. So whilst all of the clusters have a stretched isolated namespace, you're going to get no connectivity between an isolated namespace and that default namespace there. So that's federation. I think now let's drop to the GUI and let me show you some of the configuration that made that happen. It's remarkably straightforward. So for the GUI, again, you don't have to remember, you can just go back and look at the stack, and you see here this is the all-in-one node GUI, so it will always point to the node that you last configured access for. Let's log in, and it's admin, and remember our password is Contrail123 unless you changed it in the stack. So this is the initial view, it's an all-in-one, so it's saying in one node. My SDN has a vRouter, a controller, an analytics node, so it's capturing analytics for all of those flows, config node and a database node. Now, what did I actually do to get these to federate? Very simple. Look at BGP routers in config. External Contrail node. So let's take a look at one of those. Very simple. It's literally you're saying, I have another controller that I'd like you to federate into. And this is his IP address and this is his AS. And that's it. And all these address families get federated and they start to share information about your tenants, your networks, and what's going on. So if I now go to monitor, controller nodes, peers, and there you can see the full mesh. All the BG peers are up to all the other controllers. Okay, so we can see from BGP that all of these controllers are federated, but how are we actually controlling which networks stretch to which networks? Well, like I said, it's just a number. So let me go to networks. I'll pick my testing namespace this time. And you can see when I deployed the namespace, the CNI picked that up and it deployed, as I've shown you in other videos, a pod network and a service network. But what I did in the stack is I assigned that network an ASN and a root target. I assigned that for this namespace in every single controller that I want that network to stretch out to. In this case, I did it in all 10 controllers. It's a full mesh. So that means that namespace, those networks, those pods are going to have reachability. They're going to be able to see each other within that namespace, even if they're spread across other clusters. Yeah. So you start to see how federation can scale things up for you. So just returning to the wiki to wrap up. So I show you some of the commands that I was using to check Kubernetes, but I'm sure you're familiar with Kubernetes at this point. I've got some testing hints in there. You saw me playing with iPerf to run a load. Amazing figures for small instances in AWS, incredible figures in overlay. And then on the all done, so yeah, as with the other stacks, by default I'll allow management access over internet from anywhere on the planet. Probably not a good idea. So I'm telling you here how to lock it down. And then I'm not going to run through this in the video, but I've listed every stack parameter with an explanation of what it does and what its default will be set to. You're going to see an awful lot of flexibility in here. You can see here are the MX parameters for if you want to use an MX gateway, so you don't have to. So look, I hope this video is useful for you, and hopefully this stack, I mean, you can see it was a couple of clicks, half a dozen easy parameters, and you have a cluster of as many federated Kubernetes with an SDN as a CNI as you like. So hopefully this will make it a lot easier for people to look at federation and to think about how they're going to scale up their services beyond a single Kubernetes master. That's the end of the video, and thank you for your time.